Hello, geometers. This is Ms. Backfish, and I am here to go over with you a review for our circles quiz tomorrow. So I'm just going to go through these problems, and if you want, don't forget to pause and work things as we go. Make sure you can pause, you can rewind, you can stop it, try a problem on your own, try part of a problem on your own. However, you need to use this video to get the most out of it is what you need to do. So let's go ahead and write key and start here. So on number 1, it's asking me the measure of angle B. So that's this angle here. And I like to extend the sides past the edge of the circle. Okay, so its vertex, the vertex of angle B is on the circle. Remember that we have the basically rules that say that when we're looking at angles with circles, basically we want to know where is the vertex of the angle. And we do something different if the vertex of the angle is outside the circle, if the vertex of the angle is inside the circle, and if the vertex of the angle is on the circle. Okay, so our rules basically, if it's outside, the measure of the angle is half the difference of the two arcs intercepted by that angle. And we're going to do some examples of this so you're going to see what I mean. Okay, if it's inside, if the vertex is inside the circle, the measure of the angle is half the sum of the two arcs. So difference means subtract up here, and here we have the sum. We're going to add the two intercepted arcs. And finally, if your vertex is on the circle, the measure of your angle is just half the measure of the intercepted arc. Let me point out to you here the fact that this can be written a little bit differently, and you may see it differently. Here is a graphic organizer that you can see these same rules written slightly differently. Instead of half, it says divided by 2. That's the same thing. Multiplying by 1/2 is the same as dividing by 2. So this is the same as 1/2 the arc is divide the arc by 2. This is the same as 1/2 the sum is add them together, then divide by 2. And again, this is the same as 1/2 the difference. Notice that I didn't write the central angle rule because the central angle rule is just the angle is the same as the arc. Okay, so that's what we're going to be using here. So on number 1, the vertex is on the circle. So that means the angle is half the arc. So the measure of angle B is 1/2 the intercepted arc here, which is 60. Remember, the intercepted arc is the arc between the two sides of the angle. So that's going to be 30, and that's my answer for number 1. On to number 2, this is another example where the vertex is again on the circle. Here's the vertex of the angle we're looking at, angle DBC. We're looking at this angle over here. Let me trace it. And it has a vertex on the circle. So again, we're going to use the rule, the angle is 1/2 the arc. And that's the same as if I just said the angle is the arc divided by 2. So the angle here is going to be half this arc. My intercepted arc is arc DB, this part right here. The problem is I don't know arc DB. But I do know that the rest of the circle measures 192. So knowing that a whole circle adds up to 360, I can subtract 360 minus 192. Let's write that. 360 minus 192 to get this arc over here, and that's going to give me 168. Now that I know the measure of the intercepted arc, I can say, okay, the angle, which we said this is measure of angle DBC, is equal to 1/2 the measure of the intercepted arc. So half of 168. So that's 84 degrees. And that's my answer for number 2. All right, number 3 also uses some inscribed angles. This time we have a whole triangle drawn inside of a circle. Okay, and we have in this triangle 3 different inscribed angles. Now I'm going to draw in this in different colors, so hopefully it doesn't get too busy color-wise. But let's look at that angle that they gave me, 49. That angle intercepts this arc. So if it's an angle with its vertex on the circle, which it is, and the angle intercepts an arc, then the angle is half of that intercepted arc. So 49 is half of this arc. That means 49 times 2 will tell me how big that arc is. 49 times 2 is 98. So that's how I know that the measure of arc BC is 98. Next up, I'm going to look at that 70-degree angle, and I'm going to use a different color. So here it has its vertex at C. One arm goes out this way. These are the sides of the angle. The other arm goes out this way. And they intercept this arc. So the 70-degree angle goes with or intercepts this arc here. Angle is half of arc, so 70 is half of this, which means 70 times 2 tells me that the orange arc, basically from here to here, is 140. So basically the reason I did that is that now I know everything on the circle except for the part that's missing that I was asked for. So I know I have 140 here and I have 98 here. So I can add those together. 140 plus 98 is 238. So all of this is 238 degrees. And if I want to know what that missing arc is, I can do whole circle minus 238. And that's going to be 122. So that is the missing arcs measure. All right, number 4 here has another group of inscribed angles. Okay. There's a lot we could do with this one because one thing I want you to notice is you have a triangle and one side of it is a diameter. When you have a segment like this that looks like it's in the middle and it has a point right at the middle that looks like the center of the circle, that's a diameter. So if you have a triangle inscribed in a circle and one side is a diameter, that means it's automatically a right triangle. This is a right angle. So the measure of angle B, these should all have little m's, pretend they have little m's, is 90 degrees. Like the correct way to say that would be measure of angle B. So I don't want you to get confused by that. This would be measure of arc ABC, and this would be measure of arc AB. Okay, so how am I supposed to know the difference between arc ABC and arc AB? Well, they both end, well, I'm sorry, I was thinking they both ended and had the same endpoints. They don't. This one has endpoints A and C. This one has endpoints A and B. So let's just look at ABC first. ABC means go from A to C in such a way that you pass B. Remember that in every circle problem, if you have a diameter, that's your friend, because that tells you everything on one side of this adds up to 180. Everything up here on one side of that diameter has to add up to 180. So I know this part is 46. This part then must be 180 minus 46. I'm sorry, I'm moving ahead of myself, aren't I? ABC is the 180. I didn't answer that. So ABC is the 180. So now arc AB I can find by taking the 46 out of the 180. So 180 minus 46 is 134, and that's the measure of arc AB. Remember that we know it's got to be the smaller way to get from A to B, because if I went this way, I would have to say ACB or BCA to tell you I'm going the long way around. 2-letter arc name always means take the shortest path between those 2 points. All right, next up we have some more inscribed angles. Okay, all of these angles, we have angles in all of these pictures that have their vertex on the circle. So like for instance, angle CDE, D, the middle letter there, is the vertex, and D is on the circle. So that tells me the angle is half of the arc that's intercepted. So angle D is half of arc CE. So that means this measure, which they're telling me is the angle, 8x minus 9 represents the angle measure, has to be half the arc measure, which is represented by 158. So angle equals half arc. This is starting to get into where some of them, it helps to write it as an equation. And if you're going to write it as an equation, then it helps to take these and just literally fill in whatever it is you know. If you know the angle, if you know the arcs, whatever, fill it in. So angle is 8x minus 9. equals 1/2 158. And again, if you're using this other formula, that would just be arc divided by 2. That's the same thing. 158 divided by 2 is the same thing as 1/2 times 158. All right, so 158 divided by 2, let's see, what is that? 79. So 8x minus 9 equals 79. Add 9 to both sides, and I get 8x equals 88. Sorry, I need to move it up a little bit. I'm running out of space. And I end up with x equals 11. Adjust the camera a little bit so you can see this better. Sorry to make you seasick. All right, on the next picture, what they're trying to show me here is that this angle, they're pointing at the vertex to show me where the angle is. This angle has a measure of 2x plus 13. And this other angle over here has a measure of 3x. Now, one of the theorems that we learn about inscribed angles is if you have two inscribed angles and they both intercept the same arc, which these two do, then they have to be the same. Because if you think about it, the blue angle has to be half of whatever that is, and the orange angle also has to be half of whatever that is. So, like if this were a 100-degree arc, they'd both be 50. Whatever this arc is, they're both going to be half, so they both have to be the same as one another. What that means for me is I can write an equation that says 3x has to equal 2x plus 13. And then I can just solve. So x is 13. Last but not least, one of the other theorems we learned about inscribed angles is that if you have an inscribed polygon, a polygon, specifically a quadrilateral that's drawn inside a circle. So if you have a quadrilateral, a four-sided polygon, meaning you have 4 points on the circle and they're connected, that your opposite angles, what I mean by opposite angles, are not like X is not opposite from G or E, not next to it, but across diagonally, so to speak. Those are opposite angles. And these angles, angle E and angle G, those are opposite. Your opposite angles have to add up to 180. Okay, so opposite angles in an inscribed quadrilateral always add up to 180. You can't fit a quadrilateral in a circle like this if the opposite angles don't add to 180. So these two have to add up to 180. They have to be supplementary. So 68 plus 9x minus 5 has to equal 180. That's 63 plus 9x. And then I just solve. What is that? That goes 1 time 1, 3. There we go. 13. X is 13. All right, moving on. This is just about identifying parts of a circle, and this is pretty quick. Each answer will be used once. That's convenient, right? Point D. Notice that point D is a point on the circle where a line touches the circle and a line doesn't touch the circle anywhere else, just at that point. That makes it a point of tangency. So point D is a point of tangency. Line FH, okay? Line FH is this line over here. It touches circle C in one point H, and it touches circle G in one point F. It doesn't go inside either circle. It just touches each one in one point and then keeps on going. That's a common tangent. It's a tangent for this circle and a tangent for this circle. So that's what a common tangent is. It's a tangent. It's a tangent that two circles have in common, you could say. CD. CD is a segment. Here is CD. It's a segment, and on one endpoint, you're at the center of the circle. The other endpoint is on the circle. If you have a segment with a center as one endpoint, the center of the circle is one endpoint, and the other endpoint is on the circle, that's a radius. Then we have AB. AB is a segment. It tells me segment AB. It didn't say line AB. Be careful because down here it does say line AB. This is just segment AB, excuse me, which means just the part between the 2 points on the circle and including those 2 points. That's a chord. A chord is a segment that has endpoints both on the circle. So here F is segment AB. Point C is the center of my circle, so that's going to be a B. AD, segment AD. AD is also a chord, okay, because it has its endpoints A and D on the circle, but it's a special chord, and this asks me for the best description. AD goes through the center. So a chord that goes through the center, that's a diameter. And last but not least, if we were looking at the whole line AB, not just the segment, but now we start talking about going outside the circle as well. Now it's a secant line. A secant line or segment has to have points that are inside the circle and outside the circle. So it touches the circle in 2 places and has points that are in the interior of the circle and points in the exterior of the circle. All right, number 13 is telling me that AZ is a tangent, okay? So that tells me automatically that at point Z, the point of tangency, AZ, if it's a tangent, has to be perpendicular to the radius. This is a radius right here. So this has to be a right angle. There is always a right angle at the point of tangency where the tangent meets the radius. Okay, so if you have a radius drawn, it's always going to be perpendicular to the tangent at the point of tangency. So that means I have a right triangle. So that means Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. Remember, the legs are the ones that meet at the right angle. So x is a leg and 14 is a leg. So x squared plus 14 squared equals 17.5 squared. So I'm going to go ahead and simplify. 14 squared is 196. Let's see what 17.5 squared is. I can get my calculator to turn on. That is 306.25. And then I'm going to subtract 196 from both sides. I get x squared is, that's going to be 210.25. And then if you have something squared and you don't want it squared, you have to unsquare it, which means square root. I'm taking the square root of both sides. So I'm going to take the square root of 210.25, and that gives me 14.5. So x is 14.5. And that is my answer. Number 14, notice that you have central angles here. They all have their vertex at the center of the circle. Central angles always have the same measure as the arc they intercept. So like for instance, angle TXU. This angle right here that measures 87 degrees, it has to have the same measure as the arc it intercepts. So this would also be 87 degrees. This part is 72 means this part, this angle is 72. Remember that a diameter is your best friend. Here's a diameter. So everything on one side of it has to add up to 180. So I can subtract, I could take my 180 and subtract 87 and subtract 72, and I get 21. So this little part right here has to measure 21 degrees because that's what it needs to be for these 3 arcs to add up to 180. Everything on one side of the diameter has to add up to 180. Now, another thing I notice here is that I have vertical angles. This SV, which is a diameter, and UW make an X shape. So this is 72 also, which makes this 72. And finally, everything on one side of a diameter adds up to 180. So if I take the 72, subtract it from 180, that will give me WV. So that's 108. I like to do what I just did, find all the missing stuff before I answer questions about it. So arc VU, well, we just found that. So it's 72 degrees. Next thing we're getting into here is segments. This is the very last thing we have learned before our quiz. These are segments. What I want you to notice because it looks, if you removed the numbers, these pictures would look a lot like some of the pictures we've been using about the figures we've used when we talked about angles. Things to notice. There's no degrees mentioned. There are no degrees mentioned anywhere. Another thing is the numbers are centered on straight segments, not in the middle of an angle and not on a curved arc. So this is looking for segment lengths. We're talking about segment lengths. This is how I like to look at segment lengths. I tend to combine these two and say that if your segments meet outside the circle, you can think of it the same way. Both of them you can think of as the outside part times the whole part equals the outside part times the whole part. In other words, A times the whole length, A plus B, equals C times C plus D. Over here, the tangent segment here is outside of the circle and is the whole thing. So I just think of that as outside times whole, which means A is times itself. So that's why it says tangent squared. But I still think of this as being this rule. The outside part and the whole thing are just the same. So you multiply something times itself. All right, so looking at number 15 here, these segments meet outside the circle. So I'm going to use that very same rule I was just looking at. So I write it this way usually. The outer part times the whole thing on one segment equals the outer part times the whole thing on the other segment. Okay, what I mean by one segment is I mean like the whole thing here. So like there's a whole segment and here's the other one I'm comparing. So one color is one side of this equation and the other color is the other side of the equation. So let's start with the blue. The outer part is the 9. The whole thing, the whole blue segment, would come from adding the 9 and the x. So 9 plus x, not 9 times x. Think about what happens over here. If I were to ask you for the length of this whole segment, you would add 8 plus 19. You wouldn't multiply it. And same thing goes over here. You're going to have to do 9 plus x, not 9x. So outer part on the orange segment is 8. And the whole thing is 8 plus 19. 8 plus 19 is 27. I think this is actually the same as a problem we did in class today. So now I'm ready to distribute. So I'm going to distribute 9 times 9 and 9 times x. 9 times 9 is 81 plus 9 times x equals 8 times 27. I wish I could remember it from in class today. Let's do it real quick. 8 times, that's plus, 8 times 27. 216. All right, here's 216. And I'm going to want to subtract 81 from both sides. So let's subtract 81. And I get 9x equals 135. Divide both sides by 9. And I get x is 15. So there's my answer for number 15. 15 is 15. All right, let's look at 16. The difference between 15 and 16 is in 15, the segments met outside the circle. 16 is also about segment length. There's no degrees, no angles, no arcs. Segment lengths. This time, however, they meet inside the circle. Okay, the rule for inside, we tend to think of this way. Part times part of one chord, so like maybe C times D, equals part times part of the other chord, so like A times B. So in other words here, my part times part, let's color coordinate it again. That's always fun. Okay, so the blue chord, we're going to multiply the two parts of the blue chord. And we're going to multiply the two parts of the orange chord. So basically blue is one side of that equation and orange is the other side of that equation. So part times part here is 14 times 15 for the blue chord. And on the other side, 14 times 15 was the orange one. I apologize. 10 times x. So this is 210. 10x, divide both sides by 10, and we get x is 21. So that's number 16. Number 17. On number 17, notice again, there are no degree marks, no degree symbols. There's nothing that looks like it's talking about an angle or an arc. So these are again segment lengths, and these are segments that meet outside the circle. So outer part times whole for one of them equals outer part times whole for the other one. This is the one that's a little different because it's a tangent. So for instance here, the outer part is 18, the whole thing is 18 plus x. That's the whole thing from here to here. On the other one though, the outer part is the whole thing. 24 is the outer part and 24 is the whole thing. So it's kind of like 24 squared. It is 24 squared. So I'm going to need to distribute this 18. So I'm going to need to do 18 times 18. I'm going to 18 squared. That's 324 plus 18x equals, and then I need to square my 24. And that's 576. $18x equals 576 minus 324 is 252. 252 divided by 18 is 14. And that's my answer. Number 18 is a little different from anything we've looked at. Number 18 is showing me that I have two congruent arcs, this part right here and this part right here. And they're both basically chopped off from the rest of the circle by chords. And they're supposed to both be, those two arcs are supposed to be the same. So basically what that means is that the chords are going to be the same. So 9x minus 34 is going to be equal to 4x plus 1. Let's draw a little line there. And I can just solve that equation, and I get 5x and 35. So x equals 7. Now, see the difference? Number 19, we're not talking about segments anymore. We have an angle symbol. We have degree markings. Okay? So we're talking about arcs and angles. So again, arcs and angles, that's when we think about the whole outside, inside, on. Okay, like this. Where is the vertex? Outside, inside, or on? This time it's inside. The rule for inside is the angle is 1/2 the sum of the two intercepted arcs. There are two intercepted arcs, so let's look at that. They want me to come up with the measure of angle STR. That's this angle right here. Okay, so it's pretty clear that this is an intercepted arc for that angle. But we also kind of go backwards, like the angle in front of it is an intercepted arc. We also go backwards to the arc behind it. Because really, if you think about it, this angle and this angle, they're the same. They're vertical angles. So we use both of those arcs, the one in front of it and the one behind it. So this angle, measure of STR, is going to be 1/2 the sum of the arc in front of it and the one behind it. So I'm going to add, and remember this is the same. It's written with a 1/2. I could write this just as easily like this. 112 plus 186 over 2 instead of times 1/2. Same thing. This and this mean the same thing. All right. So I'm going to do 112 plus 186 and then divide by 2. It's the same as multiplying times 1/2. And that gives me measure of STR equals 149. All right, our last problem. Again, we have angle symbols, we have degree markings. This is going to be an outside, inside, on question. So here's the vertex of the angle KLM. That's the angle they want. Okay, so this angle intercepts two arcs. It intercepts this arc, the 135, and also this smaller arc that's closer, the 33 degrees. So the measure of my angle, and I'm going to go ahead and just write it without the words, equals 1/2 the difference between the two arcs. We always start with the bigger one. 135 minus 33. If you don't know which one's the bigger one, it's the one farther away from the vertex. If you did it backwards by mistake, you wouldn't get anything wrong in terms of the number. It's just that it would be negative, and you'd have to go, oh, wait, I don't have a negative answer here. So make it positive. So 135 minus 33, that's going to be 102. So 1/2 of 102 is 51 degrees. And there's my answer. Thanks for sticking with me through this. I hope it helps you a lot on your quiz tomorrow. Remember, you can go back and watch any parts of anything you need to, and I will see you later. Thanks for watching. Bye-bye.